So very good evening to one and all present here. Today we are going to see about engineering mechanics, module number 3. Already we have come across to module 1 and 2, the previous last two sessions. So in the last session we saw about different principles, law of mechanics. So in that we saw about Newton first law, second law and third law of motion, and followed by that Lami's theorem. So here we saw about one basic problem in Lami's theorem to test whether the system of forces are said to be in equilibrium condition or not. So likewise, we are going to see the two more the problems from the same concept, Lami's theorem in module number 3. And then we will go to transmissibility law of forces. So these are the things we are going to see today in module number 3. And the next module number 4, we will see about parallelogram law of forces and triangular law of forces. So straight away we will take an example problem from Lami's theorem. So consider three non-collinear coplanar forces F1, F2 and F3 acting at a point in a body or in equilibrium. Okay. F1, F2 and F3 are the three forces which are acting at a point on a rigid body which is said to be in equilibrium state. Using Lami's theorem, we want to prove practically how all the three forces, whether it is considered to be in equilibrium state or not. But in the given question, it is stated that F1, F2 and F3 are subject to equilibrium condition. Now we want to solve the given problem. So we know that the angle to the forces, opposite to the forces F2, F1, F2 and F3 are 90 degree, 140 degree and 130 degree respectively. So A, B and C value angle subject to the force acting on a body is given here. We know that the values of force F1 and F2 are 30 Newton and 25 Newton, but F3 is an unknown quantity. So we want to calculate what is the force F3 measured in Newton. In previous problem, in previous module, all the three force value, angular values are known, but we want to compare and relate whether F1, F2, F3 are in equilibrium or not by applying Lami's theorem equation. But here we want to calculate one of the unknown quantity, the force. Other remaining two values, F1 and F2 are known well in advance, but F3 is an unknown force value that we want to estimate it from the Lami's theorem equation. And the angle between each force pair that is known well in advance, A, B and C. Where A is 90 degree, B is 140 degree and C is 130 degree. Now coming to the solution, angle between the forces F2 and F3 are 90 degree in nature. So angle between the forces F1 and F3 are said to be 140 degree. Similarly, F1 and F2, the angle between the forces F1 and F2 are 130 degree. So these are the three angle values between each force pair. Now, applying Lami's theorem equation, find out the unknown quantity F3. So F1 by sine A is equal to F2 by sine B is equal to F3 by sine C. So from that, so we don't know F3. So from F1 by sine A, consider the first component F1 by sine A is equal to F3 by sine C, right? So which is the unknown quantity here, F3. So bring F3 towards the left side. F3 is equal to F1 by sine A into sine C. So from the given equation, apply all the known variables in the given equation and find out the unknown force F3 how much Newton? 22.98 Newton. So this is the given value. So we have to find out the unknown force value, 22.98, which is given here in the present slide. So another example from the same concept. So take F1, F2 and F3 are the three non-collinear coplanar forces acting on a rigid body. Angle opposite to the forces F1, F2 and F3 are 70 degrees, 140 degree and 150 degree respectively. The value of the force F1 is 100 Newton. So here in this problem, a slight difference, we want to find out the remaining two forces F2 and F3. So two unknown force we have to find out. In previous problem, only one unknown force we want to estimate it. Whereas the other remaining two forces F1 and F2 are known in advance, these two values. But here in the present problem, out of three force value, only one is a known quantity, whereas other remaining two force value, we want to calculate it, F2 and F3, as per the Lami's theorem equation. So these are the given data as per the figure. Now apply the Lami's theorem. So F1 by sine A is equal to F2 by sine B. Okay, here we want to calculate what is force F2. So bring F2 here in other direction, left side direction, is equal to F1 by sine A into sine B. So 100 divided by sine A, angle value for A 70 degree into sine B 140 degree. So find out what is F2, 68.40 Newton. Then we need to calculate F3. So from F1 by sine A is equal to F3 by sine C. So find out what is force value F3 is equal to F1 by sine A into sine C. So 53.20 Newton. Apply all the given known data in the equation. Find out this value F3. So from the above two numerical concept, the quantitative model in Lami's theorem, so it is stated that any unknown variable we can able to find out by applying the given Lami's theorem equation. Based on the known force values. From that we can find out the unknown, the quantity or any physical variable. The next one, we are going to see about principle of transmissibility of forces. So what exactly this law states? So consider a rigid body, either that is subject to rest or in motion. Let us take F is a force which is placed acting on your body, whose magnitude and direction are said to be same. Okay, acting anywhere on the body along the same line of action of the applied force. Let us take an example for a little understanding. Here, body A and B are the two rigid body connected by the rigid rod. Okay, let F is the force applied on object A. As a result, so both body A and B moves towards the right side direction depending on the pulling force F. The same force F can be replaced, that can be represented on object A. You see here the same force F whose magnitude and direction are same, and that can be replaced on object A. So here also both A and B are moved towards right side direction due to the pushing force. Whereas in previous example, the force is applied on object B. So due to the pulling action, body A and B are subject to move towards right side direction. Here, instead of pulling force, a pushing force is applied on object A. So, but the value of the force is same, whose magnitude and direction is same. But the force can be replaced at any point on the body. That is the concept, principle of transmissibility of force. A given force, we can keep it on any direction on the body along the same line of action. Even though it is a pulling action or a pushing force, it will have the same effect. It will move towards the same direction. In both the cases, the body A and B are moving towards the right side direction, depending on the applied force. That can be either stated as a pulling force or pushing force. So this is said to be the principle of transmissibility of forces. So with this introductory note, so I thank each and every one of you. We will meet in module number 4 with a further following instruction in engineering mechanics. Thank you, Ananda.